July 2021, and this is Burst 34, The Mystery of the Nine Transients. Oh, by the way, that music that I just played a little excerpt of is called Vanished. It's by a group called Aluchatistas. I thought it would be appropriate for this particular topic, which is a new paper that just came out by Beatriz Villarroel and her team at a project they call VASCO, which is the Vanishing and Appearing Sources During a Century of Observations. Now, VASCO, as you know from her last appearance on this podcast, which was November of 2019, has found quite a few of these vanishing and appearing sources in the archival plates, largely from the Palomar Sky Survey. Well, most recently they found 9 new ones that all appeared at the same time and disappeared at the same time, very close together in the sky. And they have followed that up with observations on a large telescope, as we'll discuss, and they have tried a lot of different candidate explanations to understand how this sort of thing could have happened. And that's why I invited her back on the show for a brief discussion of this paper. Now, this is not her first appearance, as I've just noted. She's been on to discuss her other results earlier, and I will leave links to those episodes in the show notes. I will also have links to the Palomar Sky Survey if you're interested in going and have a look for yourself. So I don't think she needs any further introduction since you're probably well familiar with her by now, but I'll just read the other authors of the paper. In addition to Beatriz Villarroel, there is Jeffrey Marcy, Stefan Geyer, Alina Streblyanska, Enrique Solano, Vitali Andruk, Matthew Schultz, Alok Gupta, and Lars Matson. Once again, here on the Wow Signal, we have Beatriz Villarroel, astronomer, and she is lead author on a new paper that came out in Nature Scientific Reports quite recently. The title of it is Exploring 9 Simultaneously Occurring Transients on April 12th, 1950. So let's start, Beatriz, by maybe explaining what the Palomar Sky Survey is and why you were looking closely at images on the Palomar Sky Survey.
So the Palomar Sky Survey was a survey done with the Palomar Observatory in California, and it was conducted between 1950 to, well, actually they have several Palomar surveys, but the first one was between 1950 and 1966, and then there was a second one done from 1976 to 1999. Now I don't remember the exact dates. Apologies for that. So this survey has been digitized so that the scientists today can look at the sky as it looked in the 50s, in the 60s, in the 70s, etc. And well, in those times, one didn't use CCD cameras, one used photographic plates. So it's slightly different technology, and that was used to take the images. And we have therefore been using these images from the 1950s in order to compare the sky as it was in the 1950s to the sky as it is today, because that is related to the project I work with. That is called the Vanishing and Appearing Sources During a Century of Observations project, when we compare the sky as it was in the past. In the 50s.
We'll just call that VASCO from now on, okay?
Yes, VASCO.
All right.
Oh, yes, because we simply want to compare the sky as it was in the 50s and to the sky as it is today.
Okay.
And the goal is to find some really rare transients or some really rare astrophysical events that you wouldn't find if you have a very short time window.
Right. Now, the Palomar Sky Survey was recorded at Palomar, right?
Yeah.
On using photographic plates.
Yes.
Not today's modern digital astronomy, but this was done with old-fashioned photography. As you mentioned, the plates have all been digitized. Now how did you discovered at some point while you were going through these images, you found one that was particularly interesting, and I guess the subject of this paper is this one plate, right? I should say, one scan of the plate that caught your attention. How did you discover it, and what made you think it was unusual?
So I think that in a previous burst or episode, I was talking about a paper where we were looking for, when we were doing this VASCO project, and we found 100 transients, which is like 100 short-lived things that were seen in the old images that weren't seen in the new images. Yes. And what happened was that I was, again, going through them a few times, these 100 objects, because I kept watching them. I tried to remeasure the coordinates. I wanted to measure the magnitudes. I've been working a lot with a Ukrainian collaborator that is a master of measuring, like remeasuring the photometry on all photographic plates. And then suddenly I see, wait. I'm seeing 2 transients in this image. And I was like, do I really see 2 transients? And I started again, like looking like, did I really see correctly? Went through things all again, and I can find that there are like 2 transients in this plate, and I'm just like, can this really be true? And I showed this to my office mate. We were looking at it, and was like, yeah, it looks like 2 transients. And she looked as well, like, this is strange. And then eventually I sent it to other collaborators to look at it and say, yeah, but wait, it's not 2, it's more than 2. And that's how we kind of found these very weird plates.
Okay, now this plate, all these transients occur in a pretty small part of the sky, right?
Yeah.
Actually, just a small fraction of the plate size?
Yeah, at least it seems like that, that there is a higher concentration of these transients. Like we have 9 of them within a small region of 10 by 10 arc minutes. There are a few more that actually fall outside that we have in the supplementary information, but it seems like these 9 ones are in a small region, which even further confused us.
Okay, so there's the small region there.
And then there are a few artifacts that also are like point-like, but then we compared with a different scan, and it seems to be the other ones are like scanning artifacts.
Now, by transient, we mean it didn't appear in a previous plate, right?
And it didn't appear half an hour earlier.
And it didn't appear later in any images that we have from any source. Now, so what you guys did, I thought was really great. You went and got a great big telescope. Gran Telescopio Canarias.
Yes, 10.4 meter.
Yeah, 10.4 meters. That's a big telescope. And very sensitive. It can see way down to very, very dim objects.
It's that one of our co-authors is the support astronomer there, which was, of course, very helpful to get the images.
So you looked at to a much dimmer level than the Palomar Sky Survey could look, right? Mm. And tell us what you found.
So we found that a few of them seem to have some counterparts, but 3 of them have counterparts within like 1.7 arc seconds. But you can't say that they're physically connected because when you have such a deep telescope, not deep telescope, when you use a telescope to go that deep, you actually also find a lot more background objects. And we did the statistics, and we ran the statistics, and we can't say that they are physically connected. They might be, but we can't say it.
Yeah, you came up with, a 17% chance that they were just random?
Exactly. So it's, the
sky gets pretty crowded at that very dim brightnesses, yeah. So they might be counterparts, or they might not. You can't be sure. It is possible that they appeared only once and disappeared. Now, what are some of I know you looked at a lot of possible explanations for that. What are the ones you thought were most likely, and why did you rule them out?
There were so many, I can't keep track of all of them.
Yeah, you did. You looked at quite a few. You considered naturally occurring transients, like gamma ray bursts.
From the rates of gamma ray bursts that you can observe up to this magnitude limit, you know that they are much more rare. And suddenly to place 9 of them within this small region within half an hour is just extremely unlikely.
Right. And you looked at fragmenting asteroids.
Yes, but they would leave streaks, and we could show how that they would leave streaks or something like that. And
now back in 1950, there were no satellites at all, so you can't blame Starlink for this. However, how do you rule out aircraft or balloons?
Well, they also move very, very fast, and they would also leave streaks.
Because what was the exposure time for the plate?
50 minutes. During 50 minutes, it's all going to chill.
Yeah, it would. You get streaks, definitely. So it's not planes, it's not asteroids, it's not gamma ray bursts.
We're thinking about fireflies too. Imagine if you have 9 synchronized fireflies that all blink exactly at the same time or something.
Well,
I don't think it is.
You probably get more than one set. Yeah.
So we could do a lot of that too.
Now, one of the things that you looked at, I thought that was intriguing and tricky was perhaps man-made radiation.
Yeah, we were looking
from bomb
at that.
tests.
Because apparently radiation at least can leave stars on X-ray film. I don't know if these photographic plates would be sensitive enough for that. I think it still remains to be checked. But in such case, there's a slight complication, and that's that there were no registered bombs in that year of the
Those are hard to hide. Yeah, and you think it would be on other plates as well, not just that one. If there was some kind of radiation contamination coming in,
maybe, but in such cases, something unregistered, and the question is, of course, I'm sure that there were unregistered atomic bomb tests in those times, but maybe so many years after the lists are rather complete, so maybe it rules it out. I don't know. I actually don't know, but I found this hypothesis rather intriguing myself.
Well, but you need to figure this out, right? Because there's a lot of other transients on those plates you're interested in, and if you know where these came from, then you might have some idea where the others came, or at least some of the others.
Yeah, exactly. So at least some of them, because maybe it's of course different causes for all these transients. I suspect that it's like a mixed bag, that some things are caused by one thing, others by another thing. But it would be nice to know, because if we have let's say the contamination from atomic bombs, it's good for us to know how to even detect them, so that we can not have to deal with these plates. Or
do you know Dr. Schaefer at LSU?
We have exchanged 1 or 2 emails.
Yeah, well, he's an expert on the Harvard plates.
I could ask him.
So he's not. The Harvard plates are much less sensitive. I think they're limited around 14th magnitude, something like that.
Okay.
But they're not. So you won't see these. The objects that you saw, or transits you saw. Look at your table here. They're running around 18th, 17th magnitude, something like that. So they're quite faint. They're not. They won't be on the Harvard plates. So this is a really fascinating discovery, and it looks like you did a lot of hard work to rule out the obvious explanations, and even some that are quite a bit less obvious. Do you think you'll be able to solve this mystery?
I actually don't know. That was one of the reasons why, we published the paper, is because we hope to get some feedback from colleagues that they can help us to solve it. Because I can only do a certain number of tests. I'm not skilled in everything that is necessary to solve it. And,
the paper does. For people who want to read the paper, I would say, if you're not a professional astronomer, you could probably understand 90% of what's in the paper. There's a few things that are pretty technical, but for listeners out there who want to have a look at this, I'll have a link to it in the show notes, and it's in Nature Scientific Reports, and I think so you're continuing on with your VASCO research, huh? And
yes, it's so fun.
Unfortunately, we don't have the Palomar Sky Survey. That's pretty much the most sensitive thing that we have. Going back that far. The Harvard plates go back further, but they're not that sensitive. Anyway, well, thank you so much, Beatriz, and hopefully we're gonna try to keep track of what you're doing here, and feel free to let us know of anything else that comes up.
Yes.
Anything else you'd like to add about this research, or anything else you're up to lately?
Well, I could also mention the alternative explanation for if it's not contamination. We also pointed it out in the paper, and let's say if it would turn out to actually be a real observation.
Mm-hmm.
And in such case, actually, today, if you would have the same instrumentation, there wouldn't be anything weird about finding multiple transients in a small region of the sky, because then you have satellite glints,
right,
or space debris.
Yeah.
So if you would have it in the 1950s, that maybe would be quite interesting for those who are interested in looking for probes near the Earth or so.
Oh.
So actually, these old plates are really valuable for doing solar system SETI, because there were no satellites in those times.
That is certainly something we're fascinated by here at the podcast. And yes, and I know that your research is broader than just SETI, but you've gotten some really good leads here that I think some people should follow up on. And yes, well, thank you for that. And this will be out shortly. I'll let you know. And because I don't think I need to edit it very much at all, just a little bit on the ends. So thank you so much. And I appreciate your time.
Thank you.
Okay. Bye.
Best bye.
Well, once again, thanks to Beatriz Villarroel for coming on the podcast and explaining her latest work to us. I really hope there is some follow-up on this. Whether it's to find out that there really is an explanation that was missed in this paper, or maybe it is a lead for solar system SETI. It doesn't seem like a deep sky object, if it is, or objects, if they are in fact real objects. So let's keep our ear to the ground, and maybe something will come up. And I'm sure sometime in the future I will have Dr. Villarroel back on to talk about either this or something related. As always, there will be lots of links in the show notes. Just go to wowsignalpodcast.com, and there you will get all the information you're looking for on links and also some pictures, both from the paper and from just the star field near there, so you can see that those objects are, in fact, not there anymore. Anyway, I know it's been over a year since we put out a burst, and several months since we put out an episode. And that's not because I've forgotten about the podcast or that I want to fade. Far from it. It's just that if the content is up to me exclusively, then the content will be spotty at times because of other things in real life getting in the way. And that's how it'll be until I retire. And so I thank you for staying with us and your patience, especially our wonderful Patreon donors who have stuck with us through all these different little hiatuses that I've had to take. And I hope I'll be coming back soon with some more content. Certainly, I want to have a Wow Signal pub soon, probably in August of this year. So if you're interested in participating in the pub, there's no fixed agenda, there's no topic, there's no preparation you have to do. Just show up and chat. So follow me on Twitter, Wow Signal, at Podcast Wow, or we have a little Discord server you can go to. There's links to that at wowsignalpodcast.com, or you can just email wowsignalpodcast@gmail.com if you're interested, and I'll let you know what's going on. So, that said, this is the end of Burst 34. Thank you for listening, and hope to see you again soon. The music has been by Aluchatistas and Erica Lloyd, and this podcast is distributed under the Creative Commons Attribution Share-alike license.